It's great.
Once something is seen, it can't be unseen.
Hello again. Introduce Mr. Richard Parks, President of ARP Instruments in Fredericksburg, Virginia. He and Heaton Electronics developed, or helped to develop, co-developed the soluble salt meter, which we're going to learn about here this afternoon. Mr. Parks has spent 27 years with U.S. Navy, Navy SEAL Systems Command. He was a Senior Technical Director for Materials and Corrosion. Control Engineer Department responsible for the Navy's technical authority for all paints and coatings, metallic and non-metallic, corrosion control, cathodic protection, and preservation systems. Turn to you, Mr. Parks. Thank you.
Well, when I got asked to give this briefing, I didn't know the audience because I don't know your society, but I assume everybody has to know about paint, surface prep, and inspections thereof. So I wrote this around that. I wrote this briefing not about the salt meter itself, but in the front part of this thing to give you some background of what you're dealing with, why you're dealing with soluble salts, what they do, what they don't do, some of the international standards, and how to assess and measure in the field. So, as he said, after I retired from NAVSEA, I got beat up really bad. Everybody knows the bracele patch for measuring conductivity, I assume. There's no? Okay, you gotta know this stuff then. Anyway.
Never make any assumptions.
Well, yeah, that's why I asked now. Well, you're gonna know it now. I developed, after I got out from the Navy, this particular tool, the concept of it. Then I teamed with a company in the Netherlands called Heaton, and together we developed this soluble salt meter. And it's been in the market since 2008, and it is an exact duplication and replica of the ISO standards that govern the bracele patch process, which governs soluble salts, which if some of you don't know it, you will know it when I get done with you. I'm glad you don't know it because I put the slides in so it would educate you at the same time. So it's going down too far. That's what I was afraid of. All right. So in summary, what I'm going to talk about is surface contamination, specifically soluble salts, why we care about them, what they are, what we actually need to measure and how we're going to measure it. I'm going to talk more about the generally accepted performance criteria of the salts, how much is good, how much is bad, you know, some standards the Navy has, the international community has. I'll review some of the important standards you need to know, the ISO standards, SSPC, NACE, IMO. Then I'll discuss a lot more about the bracele patch compared to the salt meter we're going to show you, the alternatives and how it works, and then actually show you the salt meter itself. So again, it's been in the business in the field since 2008. This is not going to work very well. So this slide I prepared. Assuming you're going to field, and you have to be pretty competent in this look at evaluation and review of various coating systems and their condition, as far as when they're failing. Are they blistering? Are they cracking? Are they underfilm corrosion? You know, that's just to name a few, but that education and competency takes time to learn. I'm not going to talk about all that because that would be another 200 pages to talk about. I could if you want, but I'm not today. So I'm going to focus on blistering, osmotic blistering, especially that from surface contamination soluble salts. What they are, what they do, how they break down a coating system, and then how to measure it. We try doing it this way. Yeah, that's better. So as we all know, the performance of a protected coating system is affected by the condition of the surface you're putting the coating on. And that can be surface prep, surface profile, rust, all the standard stuff you all know. That's the stuff you can see. That's the stuff you can remove and get rid of. But the behavior of that coating system is affected by these factors here of rust and mill scale, the proper surface prep, debris, contamination, and more importantly, soluble salts. Everybody in the world measures soluble salts for protective coatings in a marine environment.
You sure about that?
In the marine industry, yeah, I've been everywhere in the world, including his country, Korea, cruise ships.
I don't know about these small yards that do.
Well, small pleasure craft, no. Small yards that's doing marine.
Big yacht, yeah.
Big yachts, probably.
Yeah. Okay.
Where the big money is, yeah, they're there because it's a killer.
Around here, they just soda blast, paint, bond, paint.
Again, I had every surface ship, submarine, aircraft carrier, underwater hull, tanks, everything. So surface prep to me was critical performance stuff.
Right. It would for that area.
Yeah, and I had to get it right because the guy above me had 2 stars. But I had a blast when I was at NAVSEA. I did so many good things. I just loved that job. But I moved on. So what you see is what you get. So if you obviously compromise in rust and grease and weld spatter residues, you can remove those things by blasting for some time. You can do heat, flames, surface tools. But what I tell you is that what you can't see is what you get is the surface contamination left behind. Even if it's a white metal surface prep, soluble salts are still there. They're not visible. And these soluble salts, mostly are sodium chloride ions. That's the biggest killer. But there's other materials. There's sulfates, nitrates, and other materials. But I want you to keep focused on it's only the soluble salts in this range that affect the blistering of the coating, not the insoluble. And we'll explain that in a minute. Hey, it went down good. So this is a good slide. I prepared this one just in case a lot of you don't understand what happens, what goes on. So we have a protective coating system installed, and there are surface contamination on the surface, most likely chlorides. All right? And we're going to talk in a little while about acceptance criteria. How much can you tolerate? What's your risk factor where you won't blister, where you will blister? I'll get to that in a few minutes. But what happens in the field, especially in immersion, underwater hull tanks, ballast tanks, and everything else, and they have ballast tanks in cruise ships, right? I mean, stuff. So water, in seawater, freshwater surface, water molecules do breathe through the coating. I mean, that's a known fact, not a problem. It happens, even the best of coatings. But what happens is when it does, and there is that contamination of soluble salts with this water, you create a concentrated electrolyte solution. And what happens then is that you get what's called osmotic blistering, because there's trying to equalize equilibrium between the fresh water and the surface. And what happens is you actually break the bond of the coating and the blisters formed. Right? That's why you see blistering of coating systems. Osmotic blistering is what it's called. At low levels of soluble salts, that phenomenon really doesn't happen. And I've seen our best epoxies in the fleet, when I was there, 1,000 PSI and higher bond strength, blister. It's hard to fathom that, but they do. That's how powerful that is, that system. And it doesn't matter what boat it's applied to, it happens. So you said, yes, go right ahead, anything you want.
Yeah, we pop a blister on the bottom of the boat. It smells like vinegar. Okay.
Vinegar, yeah.
Yeah. But when you take the boat out of the water, blisters are protruding.
Yep.
Leave the boat sit for an hour and a half, 2 hours, start drying out.
Dry out.
Back in.
Yep.
Well, that drawing there, what happens with that blister?
The water, due to the heat, sun, evaporates when it rehydrolyzes when you go back in service.
Gotcha. Okay.
That's all that happens. It's still there.
So it actually evaporates.
Yeah, it heats
Because it
up.
only takes about an hour, 2 hours.
Yeah, it heats up, and
If we pull a boat, we have to look at it, and you need to see it right away, because if you wait 2 hours, the blisters are gone.
and if you pop that blister, there's water in it.
Oh yeah.
Yeah, that's what's going on here. That's a concentrated. Okay, good. So here's a little slide I was trying to illustrate basic things. So you get blistering, and then can you see this pretty good?
Mm-hmm.
So the coating fractures because of the pressure on the coating. It's more rigid, and then when it breaks, and what happens then is then you get migration of seawater, and then you get corrosion started, and then you get basically underfilm corrosion going, which is even worse. And that's why you see the growth of the blister. Underfilm corrosion, which is even worse. And that's what it looks like. A bunch of blistering, corrosion, you know, this is like undercutting under here. In a ballast tank or like an underwater hull, you would have anodes or a pressure current cathodic protection system, either one. It will protect, you know, the areas here, but cathodic protection can't go in and underneath the coating system, so it won't help you there. But it provides some protection there. And that's mainly if it's a ballast tank, if it's in immersion. If the ballast tank top, say, is not in immersion, you'll get some pretty serious corrosion in the ballast tank tops. So, and then when you do inspect tanks like that, you'll see massive corrosion around the edges, weld seams and all that. That's because the coating's real thin at those areas, and that's the first area to be compromised. Any questions so far?
I've got one.
Yep, what's up?
Blistering, can you diagnose from the pattern or the frequency or the locale of the blisters or the data that's implicated?
Well, it's really where the salts are.
Are there other forms of blistering besides contamination salts?
I'm sorry?
Are there other causes of the blistering besides the contamination?
You could have, well, soluble salts is the main thing that forces blistering. You could have some soluble materials in the paint film itself, which typically you don't, but it could contribute to that. But not really. I mean,
How about, we had a speaker yesterday talking about electrolysis and galvanic corrosion. Would be factors like that causing?
well, the electrolysis is, I should put more on the slides then, is that concentrated electrolyte cell is the cations, anions in solution. But I didn't put on there the whole corrosion cell, the anode, the cathode on the surface itself, because that's all going on too.
That's what he had touched on yesterday.
Yeah.
But that's why what you're talking about is strictly contamination and the codes applied.
I'm talking about that, but the phenomena you're talking about, I didn't get too far technical with you because I didn't know, you know, anode-cathode relationship.
That's why I just want to get clear on there are blisters that are caused by factors other than contamination.
There can be, yeah, at the surface, it could break down the coating system.
Saying poor application and too thin.
Yes, too thin, yes.
So if we're doing an inspection, contamination or poor application would probably be at the top of the list.
It probably would be if you see a large area of contamination, not too many blisters, some. That's usually an indication of port surface prep and or not enough paint per spec. Or they missed the overcoat window. It could be, I was telling you this, there's so many things you got to know. You got to know that where they behind stiffeners, where they typically miss all those areas. You got to know on the edges of those stiffeners where they don't stripe coat. All those areas can compromise a coating and form the particular.
It would be blisters like you're describing. Usually, when you're looking at this, the whole surface is covered with blisters, perhaps.
Not the whole surface. No, I don't. No, I don't see it that bad. I mean,
of an area, for example, that wall behind you is a bulkhead. Would you be looking at a handful of blisters, or would you be looking at hundreds of blisters?
Depends.
it depends how contaminated the surface was.
Well, it's contaminated by atmospheric salt or by poor washdown or solvent.
It could be all the above. Pour washdown, salt in your grit that you did. That's why you measure the soluble salts. We're going to get. That's why we do what we do. I'm getting ready to get to it.
So to answer my question, you would use your device to identify the salts.
Yes,
Okay, thank you.
the world does. So it's those visible salts you cannot see before painting that you got to know what's there. That how much is how bad the contamination is.
You would test before the paint's applied.
Yes. So anyway, I mentioned earlier, I mentioned it again, societies and owners all have their own go, no-go acceptance criteria for the level of soluble salts on the surface. The Navy has their own, IMO has theirs, other societies I'll talk about in a minute, but it's where they set a standard where they're good for their application. And I'm going to have a slide on that, so don't worry. So here's that slide. The US Navy has two values, one for immersion, one for atmospheric. And their level is by weight or by conductivity. By weight, it's 30 milligrams per meter squared and 50 for non-immersion. Now, that number has been in place for over 25 years because I'm the one who put it there. And it is still in place now. And that was determined by a number of studies to look at as far as where do I see blistering with the degree of contamination, where are my risk factors at? And then we did tons of fleet installations and tracked them. And by controlling those levels, we saw a tripling, quadrupling of the service life in our tanks and underwater hull by controlling the soluble salts. It was a great investment. And at the same time, we went to high performance coatings, high solid coatings.
Now, was that one metal only?
That's metal.
Testing?
Metal.
Metal only, okay, not fiberglass. Okay.
No. So other societies, North 20, IMO for ballast tanks and double skins, theirs is 50, and Gusan, I think it's pronounced, is 50 for pipelines. Chevron, Shell have their own, which they have meters, but I just put a few up there. These are where the owner or society sets their standards. This will always be, for the day I die, the Navy's. I know that because when it's institutionalized for over 25 years and it works and they know it, they're not going to change it. Okay, so far? So, bracele patch. That's a bracele patch with a syringe needle. Maybe I should take a second to describe how that's working. Up to 2005, that was the universal way to measure soluble salts in the field. It's governed by 2 ISO standards, which I'll talk more about in a minute. But basically, you take a latex patch, stick it to a surface, take a needle syringe, get some deionized water, inject it in the patch, swish it around, pull the water out, put it back in, come over to a conductivity meter, squirt that in there, and read the conductivity of that water. And that process, the patch costs like $5, and it takes anywhere from 8 to 10 minutes to do that process. All right, so it's cumbersome, a lot of errors in it involved with human errors, etc.
And you had to do that how often on a boat?
Yeah.
Every five times every 1,000 square feet.
Oh, 5 times every 1,000 square feet.
Yeah.
Just after it's been blasted.
Yeah, before painting. I want to stop here to explain something a lot of people don't understand, and even I didn't understand for a while. We are interested in the density, the weight of soluble salts on a surface. All right, how much weight? That's the milligrams per meter squared. But we are measuring with a conductivity meter, which is reading the conductivity of the solution you just extracted. That's how conductive it is, you know, how much current flows through that water once you extract those salts. All right, so when you take this deionized water in there, which now is extracted and dissolve those salts in it, now it's conductive, and then you put it in a conductivity and measure it, that's not the same as the weight. They're 2 different numbers. But what the ISO standards do is it gives you a value to convert the conductivity value to a weight value. So that's how we know what the weight is. So always remember that when I measure, everybody measures conductivity. The reason is because it's the fastest method in the field to do so. Otherwise, you're out there titrating, taking samples to the lab, and you can't do that in real production. But nobody ever really explained that to me. All these numbers floating around, that's the simple basics, and that's how you get there.
And they used to get there. Now you have a device.
Yeah. Good lead-in. Here's $5. So, everything I'm going to talk about now is some of the standards and the comparisons of the salt meter, which, by the way, that's what it looks like. We're going to get to it in a minute. Nice. Feels so remember, 8502-6 is the ISO standard for the bracele patch, defines the patch and what it is, period. Been there forever, and it's called the bracele method. And 8502-9 is the field measurement by conductivity, a little conductivity measurement device. So we are a conductivity meter, right? Other guidance documents, when you take this home, is SSPC Guide 15, just reissued their Guide 15 and included the methods for validating and assessment soluble salts in the field. That's a helpful document if you want it. More importantly, NACE issued, everybody knows what NACE is, right? Okay, NACE issued a method for evaluating the equivalency of a proposed yes, sir.
I'm sorry, I'm a dummy. I don't know what NACE means.
I'm not going to tell you that.
Oh, come on, be out here.
National Association of Corrosion Engineers. It's the biggest corrosion society in the world. They're located in Texas.
Okay.
Yeah. I could have said anybody knows anything knows that, but then it'd be insulting. So, no, they're equivalent. They're the guru of corrosion kind of thing, standards. They're like an SSPC or other. So, because I was the first one to come up with an alternative process from the bracele patch because it stink. And when we come up with it, here it is. Well, how do you validate the equivalency of this to the patch? How do you? I could say, yeah, it works. But so NACE issued a standard to validate equivalency of anybody's proposed alternative method to that of a bracele patch, and issued it twice. And the latest version is the 2010 version. It is a lot of testing. You're required to do third-party independent testing side by side with doped up panels and bracele patches and all that, and you get a third-party independent report. If you pass, you're good to go. We're the only ones that passed that test, by the way, and we're the only ones spec'd in by the Navy because we passed that test. It's that hard. And I'll tell you more in a minute why we passed it. The Navy's requirement here, probably never heard of it. It's called the NAVSEA Standard Work Item 00932. That is basically their Bible. It's about 70 pages long for all ships in the field for maintenance, painting, preservation practices. Not new construction, just everything in the field. If you do anything on a ship anywhere in the world, that's the document. Okay? I think the Brits follow that.
Probably.
I was just trying to bring you back in the conversation.
Probably.
I was trying to bring you back in the conversation. So the bracele patch, switching back to that. Some of the problems with it are the patch costs $5. Right? That doesn't sound like a lot, but the patch inherently does have some contamination to it, which, you know, we're trying to assess low numbers. I don't want to have a contaminated patch. Some of them are real low, some are not, unless you account for it, etc. But the patch itself, which has this area here, is a sticky residue that sticks on the surface and tries to seal, and that's the reservoir area that the water goes in. And the problem is sometimes they leak. Here you got to try to get the needle in the right way, you know, the operator dependent kind of thing. Okay?
Notice if you have a rusty surface, you're not getting anything to see.
Yeah, yeah. So.
And then if you grind it down, you're defeating the purpose.
Exactly. So it takes roughly 8 to 10 minutes to do a measurement that way. And I emphasize that because we take 45 seconds. It's all manual, all done by hand. But the biggest problem we see in the field is sometimes as much as 30% of those patches stick to that profile, especially if it's a 3 or 4 mil profile. Now you got to get acetone and other things that get all that off, and you're going to end up spending 20 minutes taking that patch residue off. So we say there's got to be a better way, right? I think that's the next slide if I remember. Yeah, there it is. So there's a better solution. That's our salt meter. Now, the bracele patch, I want to do bang bang side by side meter to the bracele patch. The surface area of the bracele patch was 1,250 millimeters. So when to design this meter, this, you'll see it on the graph up here, but this test area that we test to is 1,250 millimeters. So I want exactly the same surface footprint, all right? The amount of water that's injected by the syringe is 3 milliliters. It's getting in there, and you got to push the water in, swish it around, swish it back out, and all that stuff. Well, we developed a medical dosing system. What are you doing?
I'm just thinking of the thing, how do you switch it around if you're in a large, just like.
Well, it's a little patch, and you just,
Okay.
It's a little membrane in it,
like that.
rubber membrane.
Yeah, it's a, yeah, it's,
Yeah.
it looks like a condom with a rubber backing.
Well, who would be doing that? Like in a house?
Somebody needs a condom with a rubber backing. You stepped into that. Sorry. I'm sorry, what?
Who would be doing the use of the patch? Would this be a paint foreman or this would be?
Paint foremen, owners, contractors doing surface prep following standards they're required to do. I mean, everybody that does surface prep installation of a coating system.
Everything stops and you show up and we get syringe.
QA inspector shows up, says, show me the money.
Richard,
Yes, sir.
not an off-topic question, but if you blast a steel boat down to bare metal, you have it wash, you do this test to find the soluble salts, they wash and clean it. What is the seal up time on the raw metal? that
What
you
is the
guys
what
recommend?
time?
The seal, where you have to recoat the raw metal before you start getting contamination from
That's-
oxidation.
That's a real good question. And the answer is, it can flash rust if it's high humidity and there's still a lot of residual soluble salts on the surface. I don't know if you've ever seen water jetting done, but water jetting really strips and cleans the surface, and you can then leave that surface for 24 hours and you won't see a bit of flash rust. Why? Because you are really getting, scrubbing and cleaning all the soluble salts. So the flash rust either comes from two places: what's left on the surface, or any atmospheric, dew, mist, or whatever. That's what drives that flash rust. Make sense?
Yes.
That's why everybody hurries. They get their surface prep done. They want to get the QA inspector in so they can get it painted before they lose the surface. So, as I said before, back up a little bit. The meter replicates exactly the footprint and the process and the procedure that's done by the bracele method. The cycle time is 45 seconds between readings, which is unreal, and you'll see why and how in a minute. The meter reads the conductivity of the solution and the temperature all at once. The LED screen shows that value. It holds 1,000 readings, 10 batches of 100. And it also has a data export to transfer all your files to a computer, which I can show you that. Before we get to that, we'll talk about this. So here's the basic parts of the meter itself. I'll go through just some of them. This is the enter button that controls the screen. This is the LED light that tells you you're ready to go. Piston, not important right now. So this is the silicone seal. This is the test area. It's magnetic, which I'll show you that. So you can go in any position and measure. This thing snaps on the surface, seals that gasket, and I'm ready to take my test. So it doesn't matter what position I'm in. Okay?
What about curved surface?
Who said that?
No such
What about it? you gotta have the right parts. That's coming up next. You jump 2 slides ahead. Sorry. If I'm gonna come up here 2 hours away, I'm gonna have some fun with this. This is where the connections are for battery charging and for your download USB port. And this right here is a quick connect port where the water goes into the test chamber, which again, I'll show you that in a minute.
Battery life?
Say again?
Battery life?
Lithium ion chargeable. I hope the curves are next. Nope, not yet.
Now, where does your port? So every time you get a reading, you get a couple cents per reading.
Where is my what?
Where's your money coming from? Where's
What
your
money?
port to supply your wallet with money?
We sell the instrument.
I thought maybe you got a 3 or 4 cents per reading. I'm having fun too, man. Hey, I'm thinking ahead here.
I got you where it counts because we have 2 versions. This thing costs a ton of money to develop, first of all. So I'm justifying the cost too. But when we first introduced it, we introduced an unlimited, you buy it once, take readings forever. Readings don't cost you anything. Some people didn't want to invest a higher amount of money.
Right.
So we developed what's called a buy light version, which you get that whole meter case, everything, the bells and whistles, but it comes pre-programmed with only 50 readings, and then you have to buy additional readings. But it's cheap, very cheap. We're giving the instrument away because you have to come back to the well and buy more readings 100 at a time.
Does it need calibrating at all? Or?
It comes pre-calibrated, and once a year, suggest
Once a year, yeah.
checking it out. Mistraceable standards and
That
everything.
wasn't too far off.
No.
That wasn't too far off.
You didn't tell me there's wise guys in there. But all marine surveyors are. Deionized water, the pump thing, the hose here goes to that. So if I had my dosing system hooked up onto the water, my hose running to it, okay? And then I snap this into place. I want to put my water in, so I pull up, push down, and that puts 3 milliliters of water in there. It's pretty cool. Came right out of the medicine. Push start, I don't do anything. 45 seconds later, my reading's there. Get the meter off, a little tilt, turns right off.
Water runs out, you wipe it off, do another.
Yeah.
Is there a sealant involved in a couple of them between shots?
Say again?
You have to apply a cleaner or
No.
a couple of,
Cleaning involves pull it off, pump one through it, flushes it right out. We already know with the million study. Go to the next area, boom. Okay? Yeah, I'll show it to you when we're done. I
You did a
mean,
good job.
I'm not gonna buy it.
what?
I'm gonna buy it.
You are?
How much are they?
We'll talk later. Have I got a deal for you? There they are, pipes, round, curved. Why? Because this head comes off and you slide a different head on. There's 3 other heads. So we can do anything from flat, which it comes with, all the way up to big pipes. This is what the Saudi Arabian pipe companies over in the Gulf are all using those. Not too much in the States, but definitely in Saudi Arabia, they're using tons of these. Any more advanced questions? Because I probably have it covered. Think now.
Oh, yeah.
All right, so I just showed you how a meter attaches, so that's easy. I think you all got that. By the way, if it's stainless steel, aluminum, nickel, aluminum, bronze, what do you think we do? Wrong answer.
You set a setting on there, go with that metal.
Wrong answer. Huh? Wrong answer. God, you guys are just.
Don't do anything.
Well, you had all those other sticky things.
Yes, yes.
You guys, there's a quiz when I'm done. All right, there's some pictures in Saudi Arabia doing some pipes, yada, yada. Okay, I talked about the risk, deionized water, dumping it in, etc. One of the things I want you to keep noting is accuracy, reproducibility. So,
Always the same, always consistent.
yeah, always, yeah. Which the bracele patch is not, by the way. So 45 seconds, you can see the piston comes out. Now let me explain what's inside the test chamber. So once it seals right here, you can't see it. There are 4 sensor conductivity pins and 1 temperature pin. So after about 40 seconds of swishing and extracting the salts, it takes 32 readings of conductivity and 1 in temperature. And it averages the conductivity and gives you a true north reading. So when I first put this thing on a surface, that piston will come out to the surface to know its dwell distance. And then it'll go back, and then it'll go, and then stop. And then it'll cycle, taking the temperature readings. It's pretty cool. And then it displays your value. And it'll display the conductivity value, the weight value, and everything. Yes, sir.
So that's your technical term for washing it all around, mixing it up. Is that right?
You started it.
I was thinking, I said, I deserve that. I deserve it. It's okay. Feel all the love here, so watch. So see the plunger come out right there. Does anybody see it? Okay. And now to go back in, so that just took the distance it's got to go. All right, see it's.
Almost sounded like that too, didn't it?
Can you hear that?
That's exactly the technical term.
Sounds like a
You
bird.
see it over there? Okay. What?
Sounds like a bird tweeting. An English bird.
Go back. Go back to the UK.
Don't you have birds like that in this country?
They let you in here, huh? So now it's taking the data reading, and it's done. And guess what it says? What's the conductivity in air?
0.
Good job, guys. Okay, so that's cool. What? Hey, I'm keeping you awake, aren't I?
And it can be yours for all, but
Let's make a deal, they say. So here's the LED screen. You take a reading. Then you got your data controls, your maintenance, that's clean, validation, things like that. And then the settings, the dates, things like that. Now the cool part. You can hook it up to your computer, download all your data. All right. You guys you have to do a Coatings technical file report on what you do. So what do? There it is. There's your readings. You can't see it, sorry about that. But it's got the reading number, the date, the time, the conductivity value, the temperatures, everything you need to report is right there. Captured, hard. There's another screen.
you said that you have to do this every how often? 5 times in 1,000?
Well, an owner specs out how often. I know the Navy does 5 per 1,000, I think it is.
So you'd have to grid out and then mark that grid down as like 1, that would be on the report? Is this grid?
Well, yeah, you can say grid 1 in here. If you're going to do like a whole tank, you can pre-program one of the batches as tank 105-0. It just, here's all my readings for 105-0. Okay. And this here, still too busy for you, but basically it has everything about the meter itself. It's serial number, it's validation numbers, when it was calibrated, everything you need to know about the meter itself. So it's a pretty smart meter. Does everything but talk. So some specifications of the meter itself. It's got 1 stainless steel probe for temperatures. There's the working range, 41 to 122F. The accuracy, the conductivity pins, the range, 0 to 120 milligrams per meter squared, the accuracy, memory, etc. All right.
What's the lifespan of your sensors?
I'm sorry, what?
What's the lifespan of your sensors?
Forever. I've had meters in the field since 2008.
I didn't know if they had a.
They're stainless 316L. Yeah. So in case you haven't been drilled enough on it, here's the side-by-side comparisons that I've told you about. Equal to the patch, equal to the dosing, more accurate. It doesn't contaminate, stick to the surface. It just lifts right off because of this non-stick silicone seal. And you download your data. So you can, there's along with only taking 45 seconds to take the reading. When you're done, you're done. And there's no contamination of the surface except wiping a little bit of water off. So that's pretty cool. Dosing accuracy, I mentioned, is 0.05 milliliters. 17 steps to 5, 10 minutes to 1. All right, so all those I've drilled into you. Here's just in the States alone. I couldn't list all the ones in the world, but U.S. Navy, Naval Sea Systems Command where I used to work, it's spec'd in. I've got in a number of transportation departments, Florida, Texas, et cetera, that is spec'd it in for approved use. Chevron and Shell have spec'd it in. Just recently, GE Wind Systems for building wind towers out by Trinity in the middle of nowhere, Chicago. Just went out there. Don't want to go back. There's nothing there. U.S. Army and basically every ship construction yard and overhaul and contractor yards have these. We sell a ton of them. And you're going to buy 2, you said?
Each.
2. Got your credit card?
It's going to pay for itself within 6 months.
Actually, yeah, probably sooner. About 377 meters of readings. It's paid for itself. Resellers, basically, this is all around the world where Heaton has distributors. I own North America. That's part of our business relationship, our partnership. And how about some awards? NACE Material Performance in 2012. It was Innovation of the Year. And also by this society, it's a German society, another award, which is pretty highly recognized awards. No money involved, but it was an award. Bragging rights, right? Little summary, 8 times faster. Everything I just told you is for the quiz. There is a quiz here.
Is there some part of this patent?
It's patented. Oh, yeah.
Is it more than one item?
The salt meter itself, I have a patent in the States. Heaton has a patent worldwide. There's a couple patents on it.
So you have that.
I have a U.S. patent. They have a European patent, but together we have everything locked up. I'm not going to spend $500,000 developing this thing and not patent it.
Oh, I know.
Yeah,
What's the recalibration cost every year?
$250. That's replacing seals, cleaning and taking it apart. And that's pretty much standard. So what was your name?
Jordan.
Jordan? Okay, when you buy this, here's what you're going to get. You're going to get the whole case, which I have here. I'll show you. This is the Bi-Lite version. I told you the cheaper one. And it comes with everything in there, the meter, the case, the power cord, the dosing system, everything you need. The consumable is water, deionized water, which costs really nothing. Okay? And the Bi-Lite kit, after you use the first 50 readings, you can buy additional readings, or you can choose to buy or upgrade later to unlimited forever and never have to talk to me again. Pardon?
We go back so far, we're not continuing on.
There's a certain appeal to that.
95% of the customers buy the unlimited.
Yeah.
Because they said it pays for itself in like 300-400 readings. That's what happened with the wind systems. They use 7,000 patches a year, and they said it's going to save them a ton of money. And they're going to buy a ton of meters too. Let's see. All right, yeah. Last slide. Okay. Questions?
I can't see.
I don't want you to see it. It's the last slide.
I thought maybe there was a price thing up there or whatever.
I have literature.
What is the price for these things?
$19.95 for the Bi-Lite.
$19.95?
Sure. You just keep telling yourself that.
How much for another 100 measurements? Like it's 100.
They are batches of 100 for $6.50, so it's $6.50 a piece.
So unlimited would be how much?
5,900. That's the one that you basically get your money back after like 350 readings.
Generally, it's per shot, the charges, and how would you arrive at the
I'm sorry,
charges?
what?
How would you arrive at the charges? Is it,
How would you charge someone to go out and do something with this?
I'm not sure I understand how you're phrasing this.
Pricing,
by price, for example, with ultrasound thickness, generally it's per shot. I'm curious if there's such a thing as each reading.
Oh, well, again, so this is the BiLight one I brought. It has 50 readings in it, so you can take 50 readings, no sweat.
Which is nothing, you can do that in.
Well, exactly, but it's your choice if you only do 10 readings a
what we're
month.
saying is if a customer calls us
Yeah,
and say, I want to do my aluminum boat, I want you to come out and meter it.
okay.
What's our charge to them? What's the standard out there for charging?
I don't really know what the standard cost is for a QA inspection patch. Pardon me?
We could do it on a square footage basis.
Yeah, I don't
Criteria.
know
You're saying
what people
330
charge.
You're saying 330 tests. You pay for something.
Yeah, that's what I'm saying.
So you.
For example, for UT gauging, it used to be a figure of $10 per shot.
I'm sure it's got to be more than that because
So
your reference standard is a bracele patch, which is $5 to $6 just for the patch. So I'm sure they charge,
Then labor's involved.
yeah, about 10 or 15 minutes labor per patch. So you're looking at several $100 per doing a haul
Per shot.
per shot. Yeah, I mean,
So you're doing maybe 40.
So
$40 per shot.
oh yeah, it pays for itself in no time. I mean,
After the 5,000.
I had like Ingalls Shipyard in Mississippi just bought 10 meters. You know,
So a lot of these places are doing it themselves, though. I mean, the shipyards.
shipyards do it because
So,
they have to.
I'm just thinking where in our industry would we use this, right?
Oh, I can easily see the naval systems weapons boats we get. I mean, my recommended 12 of them in my report. And how it was saved.
To where?
No,
Norfolk?
no.
Dahlgren? For weapon systems?
Yes.
Yeah, actually my grandson works there. But yeah, they have corrosion problems on weapon systems, and they would be very interested in this for sure. I'm only 35 minutes from Dahlgren. That's where basically where I'm at. So yeah, you know, I want to tell them about that.
I mean, for what we do on a daily basis,
There's a lot of small commercial DK boats in this area. I'll give you a perfect example. The ferry boat that I work on, we had problems with a coatings adhesion problem that was due to exactly what this problem was. 65 by 30 foot ferry boat. To strip that boat down and redo it, it's $28,000. If you had one of those meters, it would have paid for itself.
right?
You know, when they did the first test.
Yeah.
So I mean, there is a lot of work in the area. These small.
Well, I think it also is due diligence. You let owners know that this is a test that even the Navy's hardcore specifies it because it affects the performance of that coating system you're going to install. You know, don't squawk about what we're doing it because it's going to save you a ton of money to make sure it's right.
So really, any industrial painter would use them to have one.
Yeah, all the contractors in Norfolk and everything everywhere.
Now, do you have to do that on every coat of?
No.
Just the initial coat? Or the metal to first coat of paint? First coat?
Yep.
And do you have any problem that sealing on rusty surfaces?
Nope. Even pitted surfaces.
Okay.
Sounds great.
I like it.
No,
It's, especially if you
I mentioned a friend of mine. It was in the severe water transfer building. He does pipelines up to 10 feet. This community, the shopping center. And I mentioned, we're going to see Richard. I am very interested to know about this. It's actually part of my bidding process. As he goes to install covered conduit. Why not?
This is somebody you were talking to?
I'm talking about this meeting and that you were going to be here talking about this equipment.
Hook me up.
There you go.
Well,
Hook me up.
Randy can buy one now. You can do the pipes for him. Someone's gonna buy one eventually. But you're already a millionaire, so you don't need it. You can give
I'm
us a
not a
couple.
millionaire.
You can give
I'm
us
a
a
billionaire. No, you know, this is one of those steady things. You just keep selling them, so many per year.
Right.
It's pretty good to do, retired, semi-retired. I just have fun with it.